Imagine looking into the night sky and realizing that almost everything you thought you knew about the universe might be incomplete. Over the past few years, astronomers have uncovered objects so strange that they forced scientists to rethink how galaxies formed, how black holes grew, and even how planets could exist. These aren't science fiction stories. They're real discoveries made by some of humanity's most powerful observatories, including the James Webb Space Telescope, radio observatories spanning continents, and space telescopes orbiting far above Earth. Tonight, we're exploring the latest astrophysics discoveries that genuinely shocked the scientific community. And by the end of this journey, you'll see why the universe may be far stranger than anyone imagined. Our story begins with a telescope that was expected to confirm existing theories. Instead, it started breaking them. When the James Webb Space Telescope first opened its golden mirrors to the cosmos, astronomers expected to see young, small galaxies slowly growing into larger ones. According to the standard model of cosmology, the earliest galaxies should have been tiny, chaotic collections of stars. But Webb immediately found something astonishing. It spotted galaxies that already appeared massive, bright, and surprisingly mature only a few 100 million years after the Big Bang. Some researchers jokingly called them impossibly early galaxies. If these measurements are correct, it means galaxies formed much faster than many models predicted. Scientists are still debating exactly how these enormous structures assembled so quickly. But one thing became clear: the early universe was far more active than expected. The discovery triggered hundreds of follow-up observations around the world. And that was only the beginning. As Webb looked even farther into space, and therefore farther back in time, it found another surprise hiding in the darkness. At the centers of some incredibly young galaxies appeared enormous black holes. Here's why that's a problem. Black holes grow by pulling in surrounding matter or by merging with other black holes. Both processes require time, often billions of years. Yet Webb found evidence suggesting that some supermassive black holes already existed when the universe itself was still incredibly young. Some contained millions or even billions times the mass of our Sun. How could something that massive grow so quickly? Astronomers proposed several possibilities. Perhaps the first black holes formed directly from gigantic clouds of collapsing gas instead of ordinary stars. Maybe early galaxies were much denser than expected, allowing black holes to feed at extraordinary rates. Or perhaps there is still an important piece of cosmic evolution we haven't discovered yet. No single explanation has solved the mystery completely. Every new observation raises even more questions. Then another unexpected signal arrived, not from visible light, but from radio waves crossing billions of light years. For years, astronomers have detected mysterious bursts of radio energy, known as fast radio bursts, or FRBs. These flashes last only milliseconds, yet during that tiny fraction of a second, they can release as much energy as the Sun produces over several days. Most appear only once before disappearing forever, but a few repeat, and that's where things became even stranger. Using multiple observatories, scientists managed to trace several repeating FRBs back to distant galaxies. Some originated from regions packed with young stars. Others came from environments that looked completely different. There was no single explanation that fit every observation. Today, one of the leading ideas suggests that at least some FRBs come from magnetars, extremely dense neutron stars possessing magnetic fields trillions of times stronger than Earth's. But not every burst matches that explanation. The mystery remains open. Every newly detected signal adds another clue, while simultaneously creating new puzzles. If radio waves weren't strange enough, astronomers soon encountered another cosmic object that challenged common expectations. an exoplanet so unusual that many scientists initially questioned whether it should exist at all. Orbiting extremely close to its parent star, this giant world experiences temperatures high enough to vaporize metals. On parts of the planet, iron may exist not as solid rock, but as vapor in the atmosphere. Powerful winds could carry that vapor across the planet before it cools and condenses, creating rainfall unlike anything found on Earth. Not water, liquid iron. Worlds like this force planetary scientists to rethink how atmospheres behave under extreme conditions. They remind us that planets across the galaxy can be unimaginably different from anything in our own solar system. And incredibly, the discoveries were only becoming more bizarre, because the next finding didn't involve a planet or even a galaxy. It involved one of the invisible ingredients believed to shape the entire universe.
The universe is filled with stars, planets, and galaxies. But according to modern physics, all of that makes up only a small fraction of what actually exists. Roughly 85% of the universe's matter is believed to be invisible. Scientists call it dark matter because it doesn't emit, reflect, or absorb light. We can't see it directly. Instead, we detect its presence through gravity. For decades, dark matter remained little more than a mathematical necessity. Then, astronomers began creating the most detailed maps ever made of its invisible structure. By combining observations from powerful telescopes and using a phenomenon called gravitational lensing, where the gravity of massive objects bends light from galaxies behind them, researchers reconstructed enormous cosmic webs stretching across millions of light years. These maps revealed something extraordinary. Dark matter isn't scattered randomly through space. Instead, galaxies appear to grow along vast invisible filaments, like glowing cities connected by highways that no human eye can see. Without this hidden framework, many galaxies, including our own Milky Way, might never have formed at all. Yet despite decades of research, nobody knows what dark matter actually is. Every new map improves our understanding of where it exists, but its true identity remains one of the greatest unsolved mysteries in science. And while astronomers searched for invisible matter, another surprise arrived from one of the most extreme objects in existence: neutron stars. Imagine squeezing more mass than our Sun into a sphere only about 20 kilometers across. The result is an object so dense that a single teaspoon of its material would weigh billions of tons on Earth. For years, scientists believed they understood how neutron stars behaved. Then, modern observatories detected collisions between these stellar remnants that completely transformed astronomy. When two neutron stars spiral together and merge, they don't simply create an explosion, they generate ripples in space-time itself. These ripples, known as gravitational waves, travel across the universe at the speed of light. For the first time in history, scientists could both see and hear the same cosmic event. The discovery opened an entirely new way of studying the universe. Instead of relying only on light, astronomers now use gravitational waves to investigate objects that would otherwise remain hidden. It was the birth of a completely new branch of astrophysics. And then came another puzzle. Some stars appeared to orbit black holes in ways that hinted these invisible giants might be affecting entire galaxies more dramatically than expected. Rather than acting only as cosmic destroyers, supermassive black holes seem capable of regulating star formation itself. As matter falls toward a black hole, enormous jets of energy can blast outward for thousands of light years. These jets heat surrounding gas, preventing new stars from forming in some regions while triggering star formation in others.
In other words, black holes may not simply consume galaxies, they may help shape their entire evolution. It's one of the biggest changes in how astronomers think about these mysterious objects. The deeper scientists look into space, the more the universe refuses to behave exactly as expected. Every answer uncovers another mystery. Every telescope reveals something stranger than the last. From galaxies that formed far too early, to black holes that seem impossibly massive, to mysterious radio signals crossing billions of light years, to planets where iron may fall from the sky, to invisible dark matter weaving the cosmic web, and gravitational waves allowing humanity to listen to the universe itself. Each discovery reminds us of one extraordinary truth. We are living through one of the greatest ages of exploration in human history. For thousands of years, people looked at the night sky with nothing more than their eyes. Today, we observe the universe using space telescopes, radio arrays, X-ray observatories, and gravitational wave detectors spread across our planet and beyond. And despite all this technology, we've barely begun to understand what lies out there. Perhaps the most shocking discovery isn't any single galaxy, black hole, or planet. Perhaps it's realizing how much remains unknown. Somewhere in the darkness, another signal is already racing toward Earth. Another impossible world is waiting to be discovered. Another mystery is preparing to rewrite our understanding of the cosmos.